Okay, example 5-4 is about a 100-meter stream with an average depth of 3 meters and bed slope of 0.05%. The average Manning's coefficient is n equal to 0.025. And downstream of the river, there is a spillway which raised the water level in the channel to 4.5 meters. So the question asks to determine the gradually varied flow classification and determine the length of the backwater profile using a 10-step in direct step method. So we need to use direct step method. So we assume that the channel bed is very wide. So with very wide channel, then we can write Manning's equation and divide the discharge by the channel width. So we divide the discharge by channel width, and then discharge per unit width will be area, which is now is already divided by the width, becomes the only depth. Then hydraulic radius in very wide channel is equal to depth. So this is hydraulic radius, which in very wide channel is equal to the depth. And then we have discharge, specific discharge equal to depth to the power of 5/3 divided by n times a slope to the power of 1/2. So that gives us the discharge. And then here we have the critical depth in rectangular cross section is q squared divided by g, and then that's a cube root. So you will get the critical depth of 1.47. So this is the schematic of the channel. So we have the normal depth equal to 3 meters. The critical depth is 1.47. Therefore, yn, as yn is larger than yc, so the channel is mild, then the channel is mild. Okay, now we go to Excel. So in Excel file, we have the slope. So this is the discharge. And then we set up the direct step method. So we have 4.5 meters. That's the depth at downstream at the location of a spillway. So velocity is discharge divided by depth. Energy is depth plus v squared divided by 2g. And the friction slope is q squared n squared divided by a squared. So a is depth. And then we have hydraulic radius square. So if you remember in our calculation, it was y to the power of 5/3. And now if you square it, it becomes y to the power of 10/3. So you calculate the frictional slope. Then we reduce the depth by 20 centimeter. So we can use an increment of 20 centimeter, or we can change to any increment we want. So we calculate velocity, we calculate the energy, and then the energy difference. We calculate the frictional slope in a similar way. Just make sure that you use a dollar sign to keep the values in place. And then we calculate the average slope. So the difference between the physical slope, which is 0.0005, minus the average frictional slope, and delta x is delta E divided by S0 minus SF average. And x is basically the previous distance minus the distance we have. Now we set this equation table, and then we can just drag it down. And that gives us the distance, so how far it is. And now you see here that when we go towards the depth of 3 meters, then you're going to have negative values. So this means that we are getting close to the normal depths. Remember, we had M1 curve. So M1 curve is a gradually vary flow curve that is above both critical depths and normal depths. So when it's getting close to the normal depth, then the values of delta X becomes, or the friction slope becomes negative. So what I'm going to do is I'm going to reduce the increments to, let's say, 5 centimeters here. Okay. And then I'm going to drag this down. So if I drag this, and you will see that we get all the distances until we get close to 3 meters. And then all of a sudden, then we'll get negative value. Yes, you see that here? Now we get close to, so up to 3 meters, the calculation looks fine. And then after that, when we go below the normal depth, then you'll get, all of a sudden you get positive value. And that's because in normal depth, the difference between the slope, the longitudinal slope of the channel, and the friction slope becomes equal. Yes. So then in that case, you'll get value. Even if I change this one to 2.99, you will see that we are going to get positive value here. So we need to stop up to here at this point. Okay, so the only thing that I think is a typo here and we need to change is that I need to put 0 here. Okay, that's it.